So we're going to look at how to transfer a pattern, 2D pattern onto a 3D surface. Could be more or less any surface or any pattern, as long as there are curves. We're going to use something called map to surface. And this is the pattern that we constructed before. I have a video of that too. So just to recap, it's a structure of attraction points here. You can move those points, and then you can also set the whole sinus modifier like this to try to alter the radiuses. These points are not there. Wait a minute, I'm just putting them in and attach them to this one. So this is how it works. That was a preview. It wasn't internalized data, so like that. And then you can start moving these points around, and you see how the pattern transfers or changes. So what if this was on a surface? It would look like this. So this is doubly curved surface, and when I start to pull around these points, it also changes there, right, as you can see. That was not so visible, so I can do it here, for example. You see what I'm doing now? I'm changing the frequency, and it's changing in both directions. It's very fast. So transferring curves is a very low CPU method, so it goes really fast. And then you can use those curves. It could be three-dimensional curves as well, by the way. So you can draw something on this surface, and then you can also then create surfaces or geometries, more complex polysurfaces and things like that afterwards using the curves. And this is, of course, also, this is a parametric surface, so if I start pulling here, the whole system changes. So it's a pretty good setup in that sense. I can pull like this, you see. And it's still then modifiable here. Goes back and forth like that. I have another video also how to construct surfaces like this one, for example. We're gonna do it fast now as well. But that's not all here. You see, this is a surface, and then I generated a thickness here on this one, and I actually made holes. So that is then done like this. This is the low part here is simply a pattern, could be whatever. What we then need, we need a reference box, a reference plane. This is the reference plane in this case. That goes into a component called map to surface, which is to be found here on transform, and map to surface is down here. So then you also need a target surface. The target surface is this one that you already saw. And the curves then come from the pattern. That could be any pattern, as I said. Mine are these circles. After that, you can do split, which will then, you see, disabled that component. And that's because it actually takes a lot of computer power. So when I start pulling around and changing, like changing this curve also, by the way, that will take a lot of computer power away. So that's why I leave it until I'm happy with the pattern. For example, this pattern, then I turn it on, and then we have to just wait a couple of seconds here, depending on your computer, of course, and then we will simply make a cut. So here you see the cut I just made, using also parametric components like these. So let's start to build this from the beginning. So in my case, I have a pattern already. So that one, that one is here. And I need to put this onto a shape. So I don't have a shape, so that's the first thing we're gonna do. That's actually the previous, I have another, the previous video, or I don't know what order it is, but I have some videos already. But anyway, for example, I can do something like I showed you, like a rail like this, and maybe I can have a second rail this time, and I will go to front view and just pull that up like this, and then I can have something like that. Let's see, that could look a bit strange maybe in the other end. Yeah, so what I'm doing now, I'm simply constructing a surface, as you can see. And I have to just only take the points so I can grab them afterwards. So like that, for example, let's see how that looks like. Yeah, that could be a nice surface. So what I would use there, you can use any construction that you want to, but or maybe you get something from someone else to put the pattern on. You don't know that. So if you double click and type sweep 2 is the one I'm going to use in this case. You can hover here and you see you need 2 rails. I already said that, right, that I had some rails there, and you need some section curves as well. I have 2 of them. So I think this is my rails, these 2, and these are my section curves. So first of all, well, we have to take those in. You know, you don't have to pull in these curves. You can take it directly in on the inputs like this by right-clicking. But in this case, I think it's quite nice to have them visible like this. Then you can see which curve is which one. So set first curve, I took a rail there, so I put that into the rail 1, and I take the next one, and I take that curve, and then it's the section curves. You will notice that I do this really fast, but the thing is that after testing a lot with surface construction, you're gonna know which one to use based on the geometry you want to make. So that's a little bit of experience and testing on the way there. For example, if I only use one section curve, it's gonna be something like this at the end, which I don't want in this case, so I have to add another one. And there we go, we have a surface. So that's our target surface, right? So we can already open the map to surface. I double click and search for map to surface, but it's also to be found, transform and map to surface there. So the pattern that I made, it's already there, right? So imagine you have a pattern coming into this curve, for example, right? You just insert that into the C. Now that's empty, it's orange, so I have to pull this one. By the way, you can scroll and hold the key at the same time. It's actually possible. So there, I have my, it's a bit irritating with this cable, I know, but that happens sometimes. So we have a target surface already, it's this one. So we take that into the target. And how do we now create a reference surface? Well, I usually use a bounding box just for that. You can draw the surface as well if you want to. I'll show that afterwards. So if you, this one is located on surface, and on privative is the first one, or you can just double click and search for bounding box. There you can add all the curves that you are working with, and you can hover on the output. You see it's 253 boxes. This is of course not what we want, so if we right click here and we go to union box, when checked, the single box for all items in each list is returned. Yeah, you can do that. Same problem. Why? It's because it's it comes from a pattern which is based on many lists. So if you simply flatten this one, it's going to be one single surface. But then again, it's a little bit too small, isn't it? So what you can do now, you can either you can also actually just go to plane here, Rhino view, and just make a plane like this or something, or maybe if you want to have a different shape. The thing is that depending on the reference surface you're gonna make, if it's gonna be, if it maybe even has this shape, or you know, something more like this, this is gonna be mimicked and taken into consideration when we map it here. So the reference surface, which is green now, is a complete copy of this, only stretched. So Grasshopper is trying to stretch this to meet every edge of this surface. You can test this to see what it looks like. But of course, I mean, my circles are a little bit outside. So if I put it in, it's already like this. Then the edges, it's directly on the edges. That's a bit strange, isn't it? Well, in my case, you can now scale this if you want to, or do it in another fashion. I would simply take all my cells from my original grid. You know where they are? Here they are. This could be my surface, my reference surface, right? So if I just take the cells and take it into the bounding box, I have a completely different situation, like that. Yeah, so that's more or less it actually, currently. Then you can play around with pulling these and test also the interconnectivity between the 2D pattern and the 3D pattern. And of course also move these points around, so you see how the surface is altering while you are looking for the result you want to have. But we wanted to also cut in this, right? And this is made by the intersection tool here. We have a lot of intersection tools, but on physical, for example, this, I mean, I won't go through all of them, but it's a good thing to just start trying all of these and see what they are and stuff like this. So surface split, if you hover here, the explanation probably guides you in finding the right component. Solve intersection events for a surface and a curve, yeah, maybe, you can try that out. Then again, it doesn't really give you any surfaces. So this is how you find things. You start hovering on the outputs and you feel like, well, there's no surfaces there. It's actually curves and things like that. It could be useful for something else, but we want to have holes. So surface split might work. Whoa, and you hover on the output, splitting fragment, empty surface parameter. That means that it's actually going to build you surfaces, right? So you can simply then, you can use the surface into the surface component. Sorry, you have to hover there, of course, as well. And then you can use map to surface into the C, but does that work? That is the question. In this case, it actually did work. The thing why I'm saying that is because map to surface, sorry, I'm gonna disable it. Map to surface, when you zoom in, there's actually many cases where it's actually not flush with the surface itself. That means it's not really exactly on it. Now I'm using circles, so it's going to be very exact, and the algorithm is going to understand it. But I do recommend to simply pull the curves onto the surface with a pull component. So if you double click and type pull, then you can pull curve onto a surface. That's perfect. You also can pull variety of geometry to a surface, but we want to have a curve now. So from map to surface, go to curve, and we go to sweep. But mind you, this is now it's definitely on the surface. So in this case, it's really hard to see. But if you do zoom in, here you saw it. You see, this is a big difference. Here we have something that's not really on the surface, and this one has been a bit transformed, right? Yes, so this one we should use to cut instead. But mind you, when this happens, this is a quite heavy calculation. So I would, if you want to sketch on, you should disable that one, and then you can start pulling around again here. Because depending on the computer you have, it's going to be quite heavy. So that goes in there, and then I can simply I can enable that and enable this one. Then it's going to take a while for it to calculate like that. Great. You might now wonder why it is so red. This is because it has very many surfaces here. Let's see. Let's see how many circles are pulled. 287. And how many surfaces are made? 587. That something is wrong, definitely. Because there should, of course, be 287 plus 1, 288 curves. Sorry, surfaces. So something has gone wrong. And consider what's happening here. So we have one surface coming in, and we have splitting curves that you want to cut with. What it does is actually it cuts several surfaces. So one of these, let's see, if we look at one of the surfaces, list item, I can just simply pick one of them, number 0, and make flatten. Does this look like it has a hole somewhere at all? It's very hard to tell actually. So it probably made a little small perforation somewhere. So it's making a a multiple split, and that takes much more power as well. So we should split with all of these together. So they're actually splitting with one list each per curve. So if we flatten this input, it's always this flattening graph thing. You should do a lot of tests and try it out so you understand what it's about intuitively. So if we flatten that, it's going to be something completely different. Now it looks like it should do. And if we hover, we have 288 surfaces. So each of these circles are also a surface. So the perforation is unfortunately not finished. But we can select the big surface. We can do that in many different fashions. The fastest way is to measure its area. So if you double click, you measure its and type area. You put that in and it's going to measure. Now it's taken a while actually. So it's measuring the area of 288 surfaces, which then in fact went quite fast. And it's also making the area centroids of them. It's a bit irritating to see that, so I usually just turn it off. And what you can do then is to sort these areas, because we know that if I hover here, I see 1418. The largest surface, that's the one I want to have. So we can sort the list by double clicking and searching for sort list. And we take the areas, of course. And then this component is pretty interesting because here it takes in different numbers, and here it has a reference for the objects that we're dealing with. And that's the surface. So we can put that in there. And what happened now is that it's actually just simply transferring the surface into this device, matching it to the areas, and then we can do from here we can pick one of them. So if we take list item again, I use list item a lot of people do that. It's a very convenient one. So list item, that means I'm going to take a specific number. On default it's 0, right? So if I then take you see the surface goes through the A and the A here. So if I go there, what happened? I'll just take this out. So it did select something, a trimmed surface. Where is it? So do you see what happened? Oh, there it is. Very small one. In fact, it's the smallest one of all of them. So in this case, I selected the smallest surface. This is not what we wanted, but this is exactly the correct way to do it. So what can we now do? So it measures the areas, sorts it from the smallest one to the largest one, and takes this accordingly with the surface split. What you can do is actually to simply reverse the list. So if you right click, you see this flatten, graft, simplify, and so forth. And on top there's reverse list. So if you click that, it's gonna just swap it the other way around, so that the largest surface comes first in the list and gets number 0 in the selection here. So if I do reverse, then we have our surface. Yeah, and then again, if you then start to pull all these curves, it's gonna be very heavy for the computer. So by the way, I can show you the whole setup. So maybe you can take a screenshot of this now. I hold it here for a couple of seconds, so you can see how I made it. I have a bounding box, went into the S component here of the map surface in order to have a reference. Any surface goes into the target, the T here on map surface, then we pulled it to be sure that it's on the surface. We made a surface split, we made a flatten on the curves, we measured the area, channeled it through a sort list component, and then we compared it to the surface frames that we cut. This is the cut frames. And then we reverse that list in order to pick the largest one. Yes, so but let's say then that I'm finished with this now, and then I want to have a thickness. Well, you can do that in Grasshopper too, but in fact it is very fast in Rhino. So if I bake it, I'll take away that, I can transfer this. Here you see the surface is very nicely built. Grasshopper can do that very good. And then you can type offset surface here. Mind you, you have to know kind of the distance you want to have. Just as a reference, I usually simply, measure something. So let's say that was 0.60 millimeters. I'm working very small now, but you can always change the units. So then you can read up here, distance is 4. That's really much, of course. Solid, yes. So if you have solid no, click this one, change this one. And I'm going to change my distance. You can click on it like that. So 0.4. And I click enter, and then I click enter again. And now it's going to take a little while for it actually does something. Creating meshes. It's working. Yes, so that's it. Now I made a very nice solid model that can be printed immediately. And printing is, of course, you export, select it, and then you can type something like, well, whatever. And here you have all the formats that you need. So, for example, STL is of course a very common one, or step file. STL is a mesh file, so step or object is of course much better geometries. Well, okay, so this was the video tutorial for mapped surface, an example. Thanks.